right, good afternoon, everyone. Okay, so we are going to start the section in this chapter where we get to deal with sleep. So, as I mentioned before, this chapter is a little bit all over the place. So we did sort of our general introduction as well as our focus in on attention and how we direct our attention, and then also how we can sort of trick our attention. And then the next couple of bits are going to be sleep, which is today. And then on Monday, I believe, we're going to get into ways of altering consciousness. And that's how they've kind of tied together things like hypnosis and meditation, as well as drugs that alter consciousness and perception. So again, very much a mixed bag of topics, but we should be pretty good to finish off here. I kind of lost track of what time we had for everything, so I had given myself lots and lots of time for chapter 6, the next one, but I kind of forgot that there's a week, so I have a whole extra week for us to cover chapter 6 that I didn't realize I had. So it'll be nice, we'll be able to take our time, because I find that chapter's a little bit different from everything else that we've done. But that's all future stuff. Let's get into sleep. And we're tying sleep into our broad category of consciousness because we can think of sleep as an altered state of consciousness. So while we're asleep, we're not necessarily aware of the things that are external to us, and we have lots of things going on internally. And so we could spend quite a long time talking about all of the different mechanisms involved in regulating and maintaining sleep, but we're going to stick to sort of those core important ones. So we're going to talk about our suprachiasmatic nucleus, or SCN, as our main control center for our regulation of sleep. And so you can see on the image there, that's that tiny little red spot. And so it's going to let our pineal gland know that it should be releasing melatonin. And we had talked about the pineal gland specifically because it was the part of the brain that one of our earlier scientists thought connected our sort of disembodied mind to our physical body. And that's not its role. It, in fact, just secretes melatonin, which helps regulate our biological clock and get us ready to sleep. And so we won't go into all of the details of this, but basically we have sensors external to our body, or I guess sort of underneath our skin, but it brings in information about light. So when we're exposed to daylight first thing in the morning, that's what kicks everything into overdrive. So we have these light levels that let us know that we need to start producing sort of a certain amount of different hormones. Specifically, we're caring about our melatonin. There's also sort of with our actual eyes that will register that, but we also have sort of separate sensors that do it as well, which are kind of cool. But that's, I guess, beyond what we need here. But this sort of daily cycle where we start with first thing in the morning, our exposure to light helps reset our biological clock. We can call that clock, that cycle, our circadian rhythms. And this isn't just sort of being awake and being asleep, but it is something fairly consistent that ends up involving lots of other systems within our body. So if we look here, we have sort of our, the lighter sort of warm color is awake, and then the darker sort of bluish color is asleep, and then awake and asleep. So we have 2 full days worth of cycles on that diagram. And we're looking at things like changes in body temperature. So when we are asleep, then our body temperature drops. And then when we're awake, it rises a little bit. And when we are sort of awake, we have low levels of melatonin. When we are asleep, we have high levels of melatonin. And then when we're asleep, we are not alert. When we're awake, we are very alert. There's all sorts of things that we can look at that cycle in this way. So these would be daily cycles, which is what the circadian part means. So circadian rhythms just mean daily cycles. And a little bit of extra information, because I think it's cool. Our circadian rhythm, if left alone, is actually a little bit longer than a full day. So if we were in a place that had no sunlight, we would sort of creep longer and longer. So we'd establish kind of like a 25-hour day. And there are mutations where people will have slightly shorter days as well. So we get reset every day by the sun. But it's kind of neat that without it, we would deviate just a little bit from what occurs naturally. And there's lots and lots of genes that we could look at that are involved in circadian rhythms. I do an entire chapter on that in one of my genes and behavior classes. But as interesting as they are, I think we'll just leave it at we have these general cycles and we involve those two tiny areas of the brain. And so if we're going to talk more about sleep, I'm going to remind you about electroencephalograms or EEGs, because this is how most of the data that's collected to look at sleep is actually collected. So that is an EEG cap. I believe you've seen one of these images already previously, but that's just a whole bunch of electrodes stuck into that cap, and they'll make contact with different parts of the surface of the head, and then it would pick up on the brain activity at the surface level underneath where those electrodes are. We can actually also see something else here. So there's a sensor right next to the eye. That isn't part of the EEG setup. That is called an electrooculograph. So it's something that specifically picks up on if our eyes are moving, so if the muscles around our eyes are moving. And we can also have other detectors in other places, so electromyographs measure muscle activity. So anything that has that graph as an ending is usually picking up on or measuring different levels. Most of the time you'll see it reported as those up and down spikes showing increased and decreased movement. And then the beginning part lets us know what we're looking at. So electro for all of these just means that they're measuring the electrical impulses. Oculo, measuring the eyes, myo, muscles, and then encephalo, meaning the brain. So just in case that helps you. I come from a bio background, so memorizing what all the different subparts of the words mean really, really helps when it comes to tests, because I have trouble putting them all together. So when we talk about stages of sleep, we have 5 general stages that people tend to agree on. These aren't necessarily as harsh transitions as what we sort of look at. There's a little bit of a bleed over in between them as we transition from one stage to the other. But for ease of looking, we're going to call them sort of distinct stages, and that's when we've switched over from one type of brain activity to the other type that characterizes the next stage. And so I have a couple of different diagrams because I found that multiple textbooks use sort of different ways of representing the same information, and I haven't quite decided on my favorite yet, so we're going to have a couple of different ones just for you to see, but they're all the same info. And so we start with stage 1 sleep. We're going to move from stage 1 through to stage 5, so that part's not difficult. This is when we're transitioning from being awake into light sleep. So this is a very, very brief stage. This is usually the first 5 or so minutes of sleep. Can be as quick as 1 minute, can be as long as 10 minutes, but this is when you're finally falling asleep. And so we have this printout here, so this would be an EEG printout for us. We've picked a single electrode that's giving us a really good idea of what's going on overall. If you were actually reading an EEG, you'd have stacks of these for the different electrodes on the brain. But for ease, we're looking at one. And so we can see at the start, we have our awake, alert EEG output. So that's when we are conscious and thinking and actually awake. So we have lots of beta waves. So we have a little bit of spread out activity, and we're looking at this as kind of the same way that we had looked at, say, sound waves, or if we were looking at waves for light. So we have time on our x-axis, even though it's not overly put in. And then on the y-axis, on our vertical, we have amplitude. So if we think about as time goes on, if we see larger peaks and valleys, that's higher amplitude, more energy. And then shorter would be lower energy, lower amplitude. And then if we wanted to talk about cycles, if we have sort of lots of space in between our peaks, that is a slower cycle. So we could talk about the frequency being a lot lower. So we're just looking at how many of those peaks are we seeing in a specific unit of time. So that should kind of establish what we're looking at with these, because we're going to be looking at a lot of them. And so when we're awake, we have lots and lots of beta waves. And as we start to get relaxed, as we start getting ready for bed, we're going to start introducing more alpha waves. So we're going to see that difference between the top one and the bottom one. The alpha waves start getting a little bit higher amplitude, so they're getting just a little bit more frequent together. And then when we drop into our stage 1 sleep, which is what we're actually here for now that we have our baseline, that's where we transition over and we start having what are called theta waves. And so you can see those as the slightly more spread out, the slower occurrence, those lower frequency waves that are highlighted there on the diagram. So they're spreading out just a little bit more, which means that we're still having about the same amplitude, but they're happening less often. So that's our indicator that we've fallen into a light sleep. And then we can start seeing these get more and more common as we move into our next stages. For other things that tend to characterize stage 1 sleep, we might have hypnic or myoclonic jerks. So that's when you start falling asleep and then your body will startle you. And there's the idea that maybe your body thinks that you're dying and is just checking that you're okay. But it's that really annoying jump that happens when you're almost asleep and your body jerks you back awake. That's what that's called. We can also have hypnagogic imagery, which is when we start sort of almost dreaming but not quite. So that sort of feeling of falling that sometimes comes with that jerk awake, that's all part of this stage 1. And then stage 2 is when we fall into a deeper sleep. So instead of just that light transitional stage, now we're into a much deeper sleep. And so we start seeing, instead of just periodical theta waves, we see mostly theta waves along with little sleep spindles. So an overall deceleration in our brain waves, much reduced frequency of those. We also see our heart rate starting to slow. That's when our body temperature starts to drop because everything's slowing down. Our muscles start relaxing, our eyes stop moving. Basically, we start shutting down to go into a deeper sleep. And so our characteristic here are those sleep spindles. And they're just sort of 1 to 2 seconds of really rapid brain activity. So in between all those nice, slow, gradual theta waves, we have a really dense cluster of activity. And those can be a little bit higher amplitude, but mostly what we care about is that they're nice and dense together, so high frequency. And then we can also see, if I sort of hop over to a slightly different diagram, same basic idea here. So we can look at the bottom there, that's a slightly different EEG output, but we can still recognize that there's sleep spindles, there's probably theta waves on either side, but now we also have what's called a K complex. And this is a period of neural excitation followed by neural inhibition. So we end up with sort of big spikes and then sort of big valleys afterwards, and then we go back to normal sort of theta waves. So these are a lot more recently characterized for this part of the brain. I've only seen it in one of my textbooks, but I figured I'd mention it because it seems like something that they're looking more and more into. And so both sleep spindles and K complexes are things that tell us that we're in stage 2 sleep. And then we move on into our slow wave sleep. And this part I always find it interesting because every textbook groups stages 3 and stages 4 together. So even though they've made this clear, okay, there's 5 stages, they just lump the 2 in the middle together for whatever reason. So we can call this our slow wave sleep. This is what happens after we've sort of transitioned through that light sleep a little bit deeper, and this is when everything really, really slows down. And so our distinction between stage 3 and stage 4, stage 3 is when we start seeing delta waves, and stage 4 is when it's almost entirely delta waves. That's the distinction they make there. If you were a sleep scientist, I'm sure you'd have other things that you care about, but that's the one that we're going to be looking at. And this slow wave sleep, this is the kind of sleep where you start recovering. This is that deep sleep that you need to actually feel refreshed. So if you were in a sleep study and they woke you up every time you started trickling into stage 3 sleep, when you finally woke up at the end of the night, you would feel exhausted because you missed out on that recuperating stage. And so it takes us about 30 minutes to reach these stages. And it's going to happen probably like 15 to 20 minutes after the onset of stage 2, so it takes a little while to transition over. Just going to push that door over. so yeah, so we've sort of deepened, oh yeah, go ahead.
Did you say that the part of it was important to get like really low rest was when you switch into 4 or when you switch into 3?
It's probably more the stage 4. Like stage 3 and 4 happen kind of simultaneously, and you're going to find that there's not a huge difference between them. It's just like higher intensity for those delta waves, and that's what we're caring about. And so if we think of this process, we had started at our stage, oh, yeah.
So basically if you take a nap for 30 minutes, it's just this and that.
Yeah, so, well, it depends. If you're really tired, sometimes you'll drop through these stages a lot faster. And we'll kind of look at how we start stringing stuff together, because when we have a really deep sleep, we're going to hit a lot of this stage 3 and stage 4 sleep, and especially when we're sleep deprived, when we start off, we're going to do a lot of the deeper sleep. So if you only napped for a couple of minutes, you might just get a little bit of this, but that feeling well rested is also kind of tied to when you wake up. Because if you were good at waking up when you're in one of the lighter stages, it's a lot less hard on your body. But if somebody comes in and wakes you up manually when you're in a deep stage of sleep, you're going to feel like you got hit by a truck. So it's kind of a couple of things that we can relate to, I'm sure. But yeah, so if we think about it, we start at our sort of stage 1, which is nice and light sleep, really easy to come back out into wakefulness. Usually you're going to transition deeper into our stage 2 sleep, which is just a little bit deeper down. And then stage 3 and 4 are that sort of nice transition between the two into that deepest stage of sleep. And then what happens at the bottom is you kind of transition back up. So you've gone through stage 1, 2, 3, and 4, and then you go back up, so into 3, so lighten up a little bit, then stage 2, and then you're going to head up towards 1, but then something weird happens, and this is when our stage 5 comes in.
High intensity delta waves are part of stage 3 or 4?
Sorry, what?
High intensity delta waves are a part of stage 3 or stage 4?
More delta waves at stage 4. Stage 3 is just when they start appearing, but 4 is when everything is delta waves. Alright, and so then our stage 5 is actually a weird one. So this is what we would call REM sleep. And so this is what happens after we've sort of dropped down to that deep sleep, we've come back up, but instead of going into like wakefulness, we end up going into REM sleep. And this ends up being about 20 to 25% of our night's sleep. But when we have REM sleep kind of depends on a bunch of factors, which I'll show you in a couple minutes. And so these cycles can last between 20 minutes to an hour at a time, again, depending on some factors. But the cool part is if you look at the difference here from our stage 4, so that deepest point that we got down to, our REM sleep looks almost really familiar. So if we hop to our sort of full stack of all of these, our REM sleep looks an awful lot like awake and alert. And in fact, it's almost indistinguishable in terms of brain waves from being awake and alert. So this is the time when we have a lot of our dreams. So we're not technically awake, but our brain is behaving as though it was, which is kind of cool. The only difference here is that we still have that slow breathing. We're still not moving around unless we have some sleep disorders that we can talk about later on. But it's kind of neat to see that we went into this sort of deeper and deeper and deeper and deeper, and then all of a sudden it looks like we're back to awake. And so this is another one of those things where I'm like, I have 2 different diagrams from 2 different textbooks that both show these EEGs. And I found one's a little bit clearer than the other, but they're the same information. So I figured I'd put both together so that we have them both. But it's showing us sort of when we're relaxed and awake and alert, stage 1, 2, 3, and 4, which this second diagram has lumped together as they are like to do, and then our REM sleep at the bottom. And so the part that I wanted to get to was what's called a hypnogram, which is their fancy term for a diagram that's showing you what stage of sleep you're in. And I have, again, a couple of these that show different kinds of information. But this is just a base hypnogram. Along the bottom we have our time, so hours of sleep, and then on our y-axis, our verticals, we have what sleep stage you're in. And so they've done it with that idea of sort of dropping down into a deeper sleep and then coming up out of it. So if we look, we start with awake. And then we're going to drop down to stage 1, to stage 2, and then down to our stages 3 and 4. And so we might see it grouped together like this one, or if I hop to my next diagram, we might see it separated out. But what you find, even when it's separated out, there's only a very small amount of time spent in sort of pure stage 3. It's more of a drop into stage 3 to get to stage 4. But the same pattern is going on here. So we see that drop down, we spend a lot of time in our slow wave sleep. We're going to come back up, we're going to go into REM sleep. Then we're going to drop back down again, we're going to go into our deep sleep. And you'll notice that as time goes on, our deep sleep, that slow wave sleep, gets shorter and shorter. So early on in the night, you're going to have a lot of that deep, deep sleep to try and recover. But as time goes on, once you've gotten enough of that, you don't need to keep going into that fully deep sleep. So we have our first time in deep sleep is long, and then a little less long, and then really less long, until eventually we don't go into that stage 3 or 4 towards the end of the night. We just stay in sort of that stage 2 area as a deeper kind of sleep. And then also you notice that our REM sleep, that starts getting longer. So the first time we're in REM sleep, it's maybe 20 minutes or so, and then 40 minutes, and then an hour. So it gets longer over time. So it's kind of like a trade-off between deep sleep and REM sleep, depending on what point you are at your sleeping. And so this one also includes the fact that we typically tend to wake up a couple of times during the night. And we're going to feel a little bit differently depending on when we wake up. Those times that you wake up and you sort of vividly remember a dream, you might have woken up during your REM sleep. Or if you wake up and you still feel absolutely exhausted, then you probably woke up during one of the deeper stages. But if we want to look at sort of this other diagram, same basic information, but doesn't include the waking up. And it does also separate out our stage 3s and 4s, which doesn't super matter. But we get the idea that as the night goes on, we're going to sleep less and less deeply, even when we drop down, and then we spend more and more time in our REM sleep. But the neat part here that this diagram shows that the other one doesn't, is it shows us why REM sleep is called what it is. So you probably know that REM is short for rapid eye movement, and that's because when we use those measurements of our eye muscles, we see that our eyes and most of the muscles in our body are held still during almost all stages of sleep. But during REM, our eyes move, even though nothing else should. So our eyes move around a lot, and that's why a lot of people associate REM sleep with dreams. So you'll find at the bottom there they have eye movements, and there's more eye movements during REM sleep. But the cool part when we look at dreams, though we do remember a lot of our dreams and we associate dreams with REM sleep, we actually dream throughout the night. And with sleep studies, what they do is they look at people's brain diagrams and say, okay, well, they're actively asleep right now. What stage are they in? Let's wake them up and see what they remember. And that's how they can tell that people can have dreams at different stages. We just don't always remember them, which makes it really hard to study if you don't have a sleep lab set up where you can tell what stage people are in to sort of check in on them. But, so even though we think of REM sleep associating with dreams, it's not the only time that they happen. You can also have dreams in other stages. So, yep.
Just be aware, like sometimes you wake or you have a dream and you feel like you've had that dream before, but it would just feel like you had a dream in REM 1 and just like REM 2 came around and you have like a similar dream, but it just felt like sometimes I wake up and it's like, oh, I had that dream like a week ago, but then it doesn't make sense. Yeah,
maybe. Dreams are a really tough one, and when we talk about sort of theories of dreaming, we end up coming to the conclusion that we have no idea what's going on with dreaming. We have some Freudian theories, which I'm sure you can imagine are very Freud-centric, but we also have like legitimate trying to figure out what the purpose is, and for the most part, we don't know. So it might be that they're completely random and we're not quite sure, and also we're not sure what's driving it. So it's really hard to study, and we can't really get a whole lot out of it.
Are you seeing any progress in like dream research field, or is it still just like no one knows what they're doing?
The last I saw, we were at nobody's sure. There are a few more theories. This time I've looked at the texts than the last time I did, so it's clearly something they're working towards. And it's a lot easier to have sleep studies now. Like, it's not as intense. And it's something that people can do at home now because a lot of the technology is a lot less finicky and you can actually have it set up. So I've seen people do sleep studies, especially to test things like sleep apnea, and they can get a pretty good measure of like your heart rate and how much you move and your breathing and all of these things. So it's getting a lot more data, but I don't know that it's actually helping us clear up any of the responses. So it's an interesting topic. It was one of the first ones that started to really bother me how little we know. But yeah. In terms of other things that we don't know with sleep, we have a bunch of different hypotheses of why we might sleep. And this is another one where there isn't really a correct answer because we can't know for sure what's happening or why it happens. So the first hypothesis is that sleep is a way of conserving energy. So if you sleep at night when it's dark, when it would be dangerous and sort of unhelpful to be out and about in the world, we're saving energy, we're kind of keeping you away from risks that might be beneficial. So if you had to sit and do nothing for long periods of time, your body may as well shut down while you're at it so you use fewer resources. That kind of ties into step 2, or hypothesis 2, which is that immobilization during sleep, the fact that we don't move around, the fact that we typically don't act out our dreams, all of that kept sort of in a safe place is helpful to avoid danger. So you're not out in the world, you're not drawing attention, you're just somewhere in a shutdown state and not moving. And then the hypothesis 3 is that idea that we are restoring energy and other resources. There is some evidence for this because we clearly feel better when we sleep. We have more repairs to our body when we sleep. And we feel a lot worse and are more likely to get sick and not recover from stuff when we don't sleep. So there is some help for that, but none of these seems to explain everything. And they're not necessarily mutually exclusive. So each of these could play a role. If we wanted to break it down, so we talked about our slow wave sleep as having a function of restoration. So that helps our brain sort of solidify things and recover. And we, again, see this where we have cognitive deficits if we don't sleep. With our REM sleep, there might be something about consolidation, so how we store memories, which we'll talk about in a chapter all about memory. But consolidation is the process of taking everything that we've encountered in the world during the day and store away what's important for future use. So if you were learning a new task, say you're learning to ride a bike for the first time, your dreams might be a little bit more likely to center around bike riding, and it might help us sort of think about and remember all of those actions involved. And then we see for evidence of this one, if you prevent people from having REM sleep, so if you do one of those sleep studies and as soon as they start going into REM sleep, you wake them up, once you stop that, once you let them sleep properly, they'll actually have overextended amounts of REM sleep. So as soon as they're allowed to go into REM sleep, they almost recover and overindulge in REM sleep after being deprived of it. So it tells us that it seems to be necessary, and not having it seems to sort of affect our memory formation, but again, not positive on how or why. So this is one of those hotly debated topics, but we do have evidence that goes along with some of these. We do know that, yes, we do conserve resources when we sleep. We do know that we're recovering and repairing when we sleep, and it does seem to have other functions, so maybe it's a combination of all of these. And we've kind of talked about missing sleep and being deprived of sleep. So this term for it is sleep deprivation, and that's when you miss your required amount of sleep over 1 or more days. So it doesn't just have to be sort of one bad sleep. It could be an accumulation of a bunch of not quite great sleeps. If you don't meet the sort of requirement of your body, if you don't sleep quite enough, over time, you can accumulate a sleep debt. So all of those lost hours of sleep build up. And there's a couple of rumors or sort of misconceptions that if you accumulate a sleep debt, then you have to pay it back in full. So if you only sleep for half the amount of time, then the next night you would have to sleep for exactly what you've missed. That's a little bit misleading because, especially as students, we learn that you end up accumulating hours and hours of sleep debt over a really, really long time. And we tend not to pay it back as a 1-to-1 ratio, but we might start seeing things like when we're sleep deprived and we finally get to sleep, we'll go into a much longer deep sleep. So we'll get more of that recovering process. So as we're deprived of sleep, we try and recover as best we can. But typically people are going to require somewhere between 7 and 10 hours of sleep a day. I'm one of those unfortunate people that needs lots and lots of sleep. So if I don't get like 9, I'm in trouble. I have family members who must be one of those people who they have a mutation that makes them need less sleep because they get up and go after like 3 or 4 hours and they're fine. But there is a genetic mutation. The gene specifically is DEC2, in case you're curious. But there are just some people who they continually sleep sort of 5 hours or less every night and have no negative side effects of it. So I don't know how they lucked out on that, but that'd be nice. If we start looking at sort of complete deprivation, if you go for an extended amount of time, if you pull multiple all-nighters, which is definitely a bad idea, you can start having some pretty negative side effects. It gets sort of the early stages are impaired attention, reduced reaction time, all that cognitive functioning stuff kind of goes out the window. And that's when we get at more risk of accidents. So maybe you're a little bit more clumsy. Maybe you probably shouldn't be driving. A little bit more likely to trip walking up the stairs or something like that. But as time goes on, it gets worse, it kind of compounds, and you can get to the point where you might start hallucinating, you might start seeing things that aren't there, and that's because the brain isn't quite functioning the way it should be. So with deprivation, if you are completely deprived of sleep, you can only last like 3 or 4 days before it can become fatal. So you really don't want to go without sleep for long periods of time. All right. And so that brings us to our next category, which is a bunch of different sleep disorders. And so we can talk about our ones directly related to sort of falling asleep. And so we have a couple of these here. So insomnia is sort of the most common one. And this is an inability to fall asleep or an inability to remain asleep. So some people don't realize that they have insomnia because they're able to fall asleep really easily, but they wake up all the time. That's also insomnia. So it's not just that falling asleep, but staying asleep. So that's the start of it. And we can have different kinds of insomnia. So we can have conditioned insomnia, which actually comes from learned associations, things that you have been conditioned to. So maybe after living as a student for many years, even when you're done, even when you work a 9-to-5 job and you don't have to get up at 6 a.m. to catch the bus, you might still wake up early because that's what you're used to doing. And you may feel bad going to bed early because you're used to staying up late. So those conditioned experiences have affected your sleep patterns. We can also have idiopathic insomnia, and that's caused by some kind of abnormality in the brain, which can interfere with your ability to sort of transition over to sleep or maintain sleep once you've fallen asleep. And then we can talk about the opposite, where you have hypersomnia, which can be excessive sleepiness, so if you're tired all the time. And that comes with the asterisks of without due reason. Again, as students, you might feel tired all the time because you're busy and don't sleep enough. That's not hypersomnia, that's just sleep deprivation. All right, so that's insomnia. What about the others? We can talk about narcolepsy, which is falling asleep uncontrollably. This is one that's a little bit interesting. I don't know if the textbook talks as much in depth about this because I like this topic, so I've kind of read up on it myself. They've specifically bred different lines of animals that have narcolepsy. So there's a gene that seems to influence having this trait. And so the most famous ones are species of goats that are a lot more likely to just spontaneously fall asleep. There's a whole bunch of YouTube videos of them sort of running through the field and then all of a sudden they just sort of flop over. That's narcolepsy. There's also specific lines of dogs that have been bred for lab research who have narcolepsy. Same thing, there's a specific gene that seems to, if it doesn't function properly, leads to this spontaneous falling asleep. And of course, they'd have lines of mice and rats to look at this as well. So there's a couple of different genes that seem to be involved in this trait. But with individuals who have narcolepsy, it can be really problematic, especially from the fact that we are bipedal. So there's a lot of distance between us and the ground when we're walking around. And so some people who have narcolepsy have to take precautions to make sure that they don't injure themselves. So they might have to wear a helmet, or they might have to wear a chin guard, because one of the most common injuries that they have is when they fall forward and smash their chin on the ground. So some people get absolutely no warning. Some people have sort of an overwhelming urge to sleep that sort of gradually transitions to sleep. That's a little bit easier to cope with, but the spontaneous kind is really damaging. We can talk about sleep apnea. This one's a little bit different, and this is related to sort of problems breathing while you're sleeping. So this can be affected by body mass, so people who are more overweight are more likely to have sleep apnea, but it isn't sort of the only determining factor. So basically what happens is when you're sleeping, especially if you sleep on your back, you might know that you're a little bit more likely to snore, and that's because you've relaxed sort of the muscles and all of the structures in your throat. And as they're relaxed, they vibrate against one another. If they relax too much, you might not be able to get air through them properly. And that's what a sleep apnea problem is that you're sort of having a collapsing of those structures so that you're not getting air through. And the way to overcome this is that people will realize that they aren't getting air, and they'll sort of wake up enough to take a deep breath and then go back to sleep. And obviously, if you're doing this every couple of minutes, it's really, really hard to get into those deeper stages of sleep. And especially where your body relaxes more, the deeper you get into sleep, it's a lot more common to occur when you're in those deep stages. So it kind of compounds itself, where the less deep sleep you get, the more deep sleep you want, and as you sleep more deeply, it's going to make you have more apneas. So that can be really problematic. It also gets more common as you get older, but it's something that you can treat. They have sleep apnea machines that actually force air through into your lungs. So you can sleep with a mask, or sometimes even just over your nose. And it just helps a little bit of pressurized air to sort of open up all the passages, get stuff into your lungs, and help you stay asleep. That's another one of those technologies that's really improved. It used to just be constant high pressure air, but now it sort of predicts how you breathe. And so it will send a pulse of air and then let up on the pressure so you can breathe out. So it's a lot less invasive than it used to be. We can also talk about nightmares and night terrors. So nightmares are anxiety-arousing dreams. They usually end up happening in REM sleep, but not always. But they tend to wake people up because they've caused that kind of anxiety. So you might wake up scared and have a moment of, okay, no, I'm fine, like I can go back to sleep. Night terrors are going to be a little bit more extreme. So this is what happens when sort of you have that intense panic, that sort of high levels of bodily arousal, so every system in your body is working, and when you wake up, it might be really hard to figure out why you've panicked. So these night terrors can be a little bit more sort of difficult to break out of. You might wake up and actually be sort of moving or trying to run from something because the feeling is so intense. So some people sort of conflate night terrors and nightmares, but night terrors are far more extreme and tend to last longer, sort of even after you've woken up. We can also have sleepwalking, so that might be kind of related to things like REM sleep behavior disorders, so moving around while you're dreaming. There's a bunch of different potential reasons for that. I know that my younger sister, she has this thing where when she has dreams, she acts out her dreams and has since she was a child. So she'd wake up in the morning and we'd be all like, soccer, huh? Because you knew exactly what she was doing in her sleep. So that would be one of those REM sleep behavior disorders. We're supposed to have an inhibition of our muscle movement while we're sleeping. That's part of that going to sleep. but it doesn't always stay in action.
The sleepwalking, does it happen when kids? Because I know a lot of people who in their fifties or want to do it.
Yeah, it's a lot more common as children, and even a lot of the sleep disorders, you tend to grow out of them. So there's some theories that it's relating to like the fact that your brain is developing and changing, and then as we get older, as our structures kind of finalize and settle, then we have less of those problems. But I also know people who didn't sleepwalk as children and now do as adults. So I don't know if that's due to sort of trauma or physical damage or what, but it's not something that's constant always. Yeah, I think that's what I wanted to talk about for those. So lots of different ways that things can go wrong with sleep. And as you can tell from most of these discussions, we don't necessarily know exactly what's causing all of these. So there can be physical causes, there can be psychological causes, there can be a combination of them. They can be temporary, they can be long-term. There's all sorts of variety here. And so as we learn more about it, I'm sure we'll start seeing more and more about this. It's one of those classes where everything else I can say, oh yeah, there's a whole class on this. But with sleep disorders, I haven't encountered that yet. So maybe sometime in the future. And then we can come back to dreams, which we kind of touched on briefly already, but these are sort of our mental experiences that we have during sleep. And we mentioned that they are fairly common during REM sleep, but that's not the only time they occur. They are usually made up of familiar content, but I kind of disagree with that. I tend not to dream about familiar things. I dream of very odd, random things. But there are a lot of common themes between different people and even across different parts of the world. So there are some consistencies with like content, what we dream about, and things that are important to us and that seem to reappear in our dreams. There's a difference in framing in different cultures about what dreams mean or how we interpret them. Some people will align more sort of importance or meaning to what we dream about, and others not so much. But it's a kind of interesting thing that is common for everyone. The neatest thing I found about this is dreaming is pretty much universal. So even people who don't see, so people who've been blind from birth, they still dream. It just doesn't involve the visual aspects that we're used to as sighted individuals. So it's not exclusive to people who have sight, which was kind of interesting to learn. When Freud was originally talking about this, he started about the idea of sort of day residue that spill over from our everyday lives. So if you're worried about a test, you might dream about that test because your reality has spilled over into your unconscious. We also have the weird case of lucid dreaming. So sometimes you know that you're dreaming and can control your dreams when you're aware of it. And that's an interesting thing because you can actually learn to lucid dream. So there are a bunch of different techniques that you can use to be more aware of the fact that you're dreaming. But yeah, that's another one of those weird situations. If we wanted to talk about some of our theories on why we dream, we can of course start with Freud that I hinted at before. So Freud's big theory with dreams and why we dream is that dreams protect us. So dreams would be our guardians of sleep. And with what we've talked about from Freud before, none of this should be overly surprising. But the idea is that when we're awake, we have sort of this ability to suppress all of that deep, dark, under the surface stuff. So all of that is trapped in our unconscious. But when we sleep, that part of us that holds it all at bay, which we would call the ego, or a mental censor, the stuff that keeps all of the things in our unconscious in the unconscious, that relaxes, and then all of that stuff in the unconscious can kind of bubble to the surface, and it comes out in our dreams. So to Freud, this would be a way for us to act on those aggressive and sexual urges without actually bleeding over into our real lives. Obviously, this is not a theory that many people still hold with, but it was a good start, as with much of Freud's work, because he made enough people angry to come up with other solutions. So we can talk about the activation synthesis theory, and this one goes almost in the exact opposite direction. And it basically says that Our dreams are caused by our brains just randomly activating. There's no real purpose for it. There's no real drive to it. It's just happening because our brain is doing stuff in the background. So when we're asleep, we're resetting, we're recovering, neurotransmitters are moving around, we're checking that stuff is still functioning, and having all of those pieces sort of firing and moving and resetting tends to be interpreted as one of the things that we dream about. So it would be a haphazard and chaotic pattern of neural firing that isn't meant to have a purpose, but because it's activating the parts of our brains that's associated with seeing and hearing and experiencing things, we're trying to make sense of that randomness, and we turn it into dreams. So this would be our forebrain doing its best to take that weird, random information and make sense of it, which people point to the strangeness of dream logic as sort of an explanation for this being true. We also have an evolutionary hypothesis of dreams, which suggests that the content of our dreams is actually something that's biologically relevant. We kind of talked about this in terms of sort of our sleep process being required for consolidation of memory. So we often dream about things that are related to sort of interacting with our environment. So if you're learning a new task, you might dream about it, and that helps you consolidate that knowledge better. And so this would focus on the fact that maybe we dream because it helps us remember skills that help us survive better. And of course, it's really hard to get proof for any of these. We can't necessarily know why something has come into being, but we can definitely say that, yeah, we do seem to dream about things that we've done, and we might remember tasks better after sleeping on it. We also see things, some of our cognitive theories focus in on our brain sort of running stuff in the background. So when people tell you to take a step back from a problem and it might come to you, especially in a dream, that would help us sort of separate from all of the constraints of our conscious mind and letting our sleeping mind sort of come at it from a different angle and maybe have some creative solutions. Though, having kept a notebook at my bedside table while doing my degree for writing down important thoughts, I've learned that sleeping brain is not necessarily good at meaningful ideas. So you might wake up to something that's like, oh yes, this was the best idea ever, it needs to go in my thesis, and you look at it in the morning and go, no, that's fine, I'm better off without. And we also have sort of the idea of our conscious processes being reflected in our dreams. So dreams are just basically using the same mental setup or framework that we use during our day-to-day lives, and they just continue to be active while we're asleep. And again, none of these necessarily need to be completely true or completely false, and we can't necessarily tell which one is right, but some of them are a little bit more credible than others, is what we can say. But that is perfect timing because it brings us to the end of that section and means that we get to start on alterations of consciousness next week. So, yeah.
So we like swear by cat naps, and like they say, they take it 20 minutes or 30 minutes, but if it takes 30 minutes to get to that deep sleep, how would that be restful?
Well, it's not that you only recover when you're in that deep sleep. You can also have some benefits, even just for like on the mental side of things, just that brief shutdown, because you're slowing things down a little bit, so you might have a little bit of a kick when you wake up again. Yeah.